please. I think we should be live by now. And I just say hello. Yes, I did manage to mute myself. Hey, folks. Welcome back to another virtual Kotlin user group session. When I look over there, it's not me being impolite. It's me checking how many people we already are. We are currently by 10, well, around 10-ish. It's fine. Happy to be back. Happy to have with me David, which we will hear and see in a second. And also with me are the two new good souls helping with the whole virtual Kotlin user group organization and things. And down to reasons, we are going to start with a couple of announcements. And I would suggest Julian, go for it.
Sure. Hey, everyone. Because of this, I'm going to be short. We just want to mention there's 2 CFPs closing in 2 days. So I don't know if you have seen them, but Kotlin Conf has been announced. And I'm going to paste the link. And I'm sure Nicola has already sent quite a few CFPs there. But yeah, the call for paper is open for another 2 days. And it's in May next year in Amsterdam. And there is also the Advanced Kotlin Day coming up in November. This is also in Amsterdam. And the CFP is also open for a couple of days. So don't hesitate. Yeah, send your papers and maybe we'll see you there. And that was it for me. I'm going to prepare food now.
Excellent. Have a good one and don't steal too much from your child. All right then. I will also add another CFP, which will start hopefully later today or early tomorrow, which is we will run the Java event again. So if you're interested, check out javaevent.com. And the CFP will be open until mid of October-ish. I will put all the things on the website and send out emails and will spam the Kotlin Slack as well. And that's it on my side. Randy, do you have anything to add there? All right, then. This is nearly it from our side on the beginning. Just wanted to say, if you like what you see, press this like button you see there. If you don't like it, tell us why. And if you click this like, nobody will see it. And if you haven't done yet, click the subscribe button and follow us, and maybe even this little bell thing to get notified when we are online. And that's essentially it from me. I will shut up now, doing my best, and it's all your floor, David.
Yeah, great. Thanks, Holger. So start by sharing my screen. Okay, so yeah, thanks everyone for fronting up to hear about KSP. So from my side, I've been using KSP since 2021. I've done a few projects in it, and I think it's a really clean API. I think it's great. I can't shut up about it. So hence this presentation today. I'm acutely aware this is a Kotlin user group. It's not an Android user group. So what I've tried to do is adapt a presentation that I gave at Chicago Roboto and just kind of strip a little bit of the Android flavor from that. So Chicago Roboto is an Android conference that we had earlier this year. And one of the really cool things is previous presentations have talked about really unique things about the city of Chicago, so like the Sears Tower and so on. So when I was giving the presentation, I thought I'd give it a Chicago theme, but actually honor the University of Chicago, which is one of the most important universities in the US. And I'd give the presentation a theme by naming it after 20th century literature. So first part of the talk is called a metaprogramming feast, and that's when we're going to talk about what metaprogramming is and why it's important. And the second part is called a farewell to Stubs, and that is when we're going to show you how KSP can help you achieve your metaprogramming goals. Third part is called the old man and the ID, and that's when we're going to actually try and build a very, very simple KSP annotation processor together And that's to inspire you so you can see, okay, well, that doesn't look so hard. I can probably attempt that myself. And the last part is called the Great KSP. And that's when we're going to talk about some of the more advanced features of KSP so that when you go to max out your annotation processor, you're not going to get stuck. You're not going to get stuck with the wrong design and so on. So there are links for you to follow along in GitHub. GitHub.com/draws/Codegen KSP. That's an Android project. There is a Kotlin, a plain Kotlin project, which is on the second link there, which is an article that I wrote previously. It's a little bit outdated, but you can still follow along if you're not an Android person. So, right, onto the first part. Now, we've called this a metaprogramming feast, and we say we're naming it after 20th century American literature. So this is named after a movable feast, which is Ernest Hemingway's biographical work about his time in Paris. So that's a bit of a reach, but some of the other titles are a bit better. Now, what is metaprogramming? Essentially, it's programs about other programs. So one common application is dependency injection. And in dependency injection, you have your program, in particular, the @inject annotated constructors of your program. And you have some kind of dependency injection framework. And that program, the dependency injection framework, will take your program and output other programs. So factories, glue code, and so on. And you can see how useful that is when you actually manually instantiate an object graph for a test. So, okay, this is an Android view model, but it could easily be some other Kotlin code that you write, and you can see you're invoking constructors which are invoking other constructors, and it gets very, very complex quite quickly managing all those constructors. But in your production code, hopefully you've annotated your constructors with @inject, and what that means is it's now very, very easy to get an instance of the class that you want, and dependency injection is handled as a cross-cutting concern. Now, it's not just dependency injection, of course, where we use metaprogramming. So some common applications that you see are in JSON parsing. So when you're using a framework like Moshi or JSON, and also for better or worse, they're used in ORMs. Like so when you're trying to abstract over some database and you want to make your access to the database easy. So when you go and use metaprogramming, there's two approaches you can take. You can use reflection at runtime or code generation at build time. Now, we all know that if we use code generation, it's going to add something to our build times, and our build times are very, very precious. So we might think, okay, well, let's just use reflection and we'll save on all this cost on the build times. But reflection isn't always a great fit. So in particular, when something goes wrong with reflection, you're only going to find out at runtime, and that might be too late. We want to catch errors early and prevent them from propagating further. So to fail fast or to shift left, however you want to call it. The other thing is, with code generation, the output is code, and because we're so used to reading code, it's very, very easy to see where something's gone wrong. You can put a debugging breakpoint on your on the generated code and inspect it and so on. And it's much better in that respect than something ethereal that is created just at runtime that you can only see with your debugger. So reflection, it's great, but there might be reasons that you'd want to avoid it. Wouldn't it be great if we could have best of both worlds? So if we could have fast builds as if we'd use reflection, and then this fail-fast behavior of code generation. And hopefully this is what KSP is going to give us, and we'll talk about that in this next section. So that was us talking about what metaprogramming is and why it is important. And now the second part is called a farewell to stubs, and that's why we're going to talk about how KSP is going to help you achieve your meta programming goals. And that section, of course, is named after Ernest Hemingway's famous novel called A Farewell to Arms. So KSP is a new API from Google. It was announced in Google I/O 2021. And it replaces legacy annotation processes that you would have written using the javax API. So these quite old APIs that are very idiomatic for Java and not so suited for Kotlin. And in the context of a Kotlin project, those annotation processes would have run with a tool called kapt. Now, kapt is a great piece of engineering that allows us to use annotation processes from Kotlin code like pretty much seamlessly, but there's some defects or some disadvantages using kapt, which we'll go into shortly. So kapt is now in maintenance mode. The new way of writing annotation processes is with KSP. And in case you think, stop trying to make KSP happen, KSP is not going to happen. KSP is happening, so a lot of annotation processes, very famous ones, have already migrated to KSP, or they have issues in their issue tracker that track the migration. So I really love this tweet from Zach Swears about why it's necessary to move from kapt to KSP. So if you think it's just a matter of swapping out one legacy kapt annotation processor with the KSP version, and you're going to avail yourself of all these improvements in your build, it's not quite that simple. So what we need to be aiming for is a Gradle module, or even an entire application that doesn't use any kapt annotation processes at all. And what that will do is that will get rid of some of the expensive Gradle tasks which kapt uses, and that will really improve your build times. So why is that the case? So this tweet also answers that. It talks about stub generation here, and we'll go into what that is shortly. So the title of the presentation was A Farewell to Stubs, and what are these stubs we keep hearing about that are slowing us down? So to give an example, I took an Android project from a few years ago, the Sunflower project, and built it. It uses an ORM called Room, and uses the kapt version of that, so the legacy version of that tool. When you build that project, you're going to end up with a directory structure that looks like this: build/tmp/kapt3/stubs. What kind of things do you get in that directory? Well, let's say I have a production class that looks like this. So a entity that I want to store in the database, and you can see I've got all those really nice annotations there that are going to allow the meta programming framework to perform this heavy lifting for us. If I have a class like that in my production code, then when I build the project in that stubs directory, we're going to find this Java version of the class. So kapt is effectively written out that Kotlin code in Java, and you can see that this set garden planting ID method body is actually empty, doesn't do anything. So it's stubbed out just like a test double that you would use as just like the stub test double. So looking at that in terms of the Gradle tasks, first task in running in building that project would be that we're interested in is kapt generate stubs by Kotlin. And I've put the turtle emoji there because that task is slow. And the reason it's slow is because it requires extensive symbol resolution, and we'll explain what that is shortly. Why do we need those stubs? Well, those stubs are needed in the next phase, which is called kapt by Kotlin. And in kapt by Kotlin, we're going to run apt, which is the legacy Java-based annotation processing tool. That tool only works with Java code. It doesn't work directly with Kotlin, so hence the need for Java stubs of our Kotlin classes. That's going to give us some Kotlin sources or some Java sources, but in any case, we're going to have Kotlin sources there, and they need to be compiled with compile debug Kotlin. Compile debug Kotlin is going to give us compiled classes, and if at that stage there's any Java sources left that might reference a Kotlin, the Kotlin classes, then we compile them together in a stage called compile debug Java with Java C. So you can see there's this 4-stage pipeline there, and the first task is computationally expensive and slow. So let's compare that with the Gradle task for running that pipeline with KSP. You can see there's only 3 stages there: KSP debug Kotlin, compile debug Kotlin, and compile debug Java with Java C. And in this first stage, you do have some symbol resolution, but it's extremely judicious and smart. So we're avoiding the need for a large amount of this expensive symbol resolution. So to explain what that is, let's look at a typical compiler pipeline. So we have some code that looks like this, and first stage is parsing, where we take that code and put it into a tree-like structure called an abstract syntax tree. And at the stage of parsing, you might think of the nodes in the tree as being name only. So we understand that there's a function generation, and maybe we know the name of the function. We understand that the function is declared inside a class, but we wouldn't understand the return type of the function or how that type relates to other types in the code. So in order to move from the realm of name only into the realm of meaning, we have to actually perform resolution, and that's what is expensive. So once we've done that, of course, we go on to generate intermediate representation and finally some kind of output. So whether that's JVM bytecode or whether it's JS code, so on. So we've talked about the reason why kapt is slow and how KSP improves on that. Let's actually go now to the IDE and write some code together. So this section is, of course, The Old Man in the IDE, and it's named after Ernest Hemingway's novel, The Old Man and the Sea. So just switch to the IDE now. Now we have a Android project here, but it could easily be a plain Java project. If I look at the settings.gradle, there's 3 modules. So the app, which is the entry point, and then a module for where we write our processor, and then a module for where we declare our annotation. So let's look at our annotation first. So we've declared a annotation called int summable. Explain what output we want from this annotation shortly, but it's going to target a class, and we want it retained in the source code so that the annotation process can see it. Now here we've got this processor module, and I'll just look at the build.gradle for that first of all. So of course, because we're writing an annotation processor, we need the KSP API, and we're going to use Kotlin Poet for our code generation. So Kotlin Poet is a very well-established, reputable library for writing Kotlin code. It has interop with KSP via this artifact here. We're going to use this auto service for service discovery, and you certainly don't have to use this, but I find it makes it easier. And then finally, you have this, we're going to test this annotation processor using an artifact called Kotlin compile testing. So let's have a look at the tests. So I'll close that because it's kind of distracting. Hopefully it's okay to see the code here. Now I've just set up the skeleton for a test here. So every time we want to compile something for this for using the Kotlin compile testing artifact, we have to create an instance of Kotlin compilation, and you obviously have to supply some configuration there and do that every time. So we just put that in a private function so it can be referenced from every test. And then we just like we're obviously going to compare some expected code with some actual code, and we'd like some syntax highlighting there, and we can get that via the @language annotation. And we can just clean up some of the API by using trim indent there on the expected and actuals, just to make our lives a bit easier. And lastly, we've just got one function here for reaching into the temporary folder in our Kotlin compilation and just finding the generated files. So I think this is actually copied from Moshi. I think Moshi was doing it that way. So I'm going to start by writing our test. Now, I'm not a test-driven development zealot by any means, but I think it's just useful here to understand what our final goal is. So we have some source. I'm going to create a source file, and it's obviously Kotlin. It'll be original and call it foo.kt because everything seems to get called foo. And obviously we have to import annotation. So in symbol annotation, and we'll write it out there. And we're going to declare a data class and just put some random properties in there. So we'll have x typed as int, y typed as int, and then just to mix it up, we'll have z typed as a string. And just to mix things up a bit, we're going to declare an extension property as well. So what's the output we want given that in symbol annotation? Well, what we're going to aim for is a extension function in a separate file that looks at the properties typed as int and outputs a function that sums those together. So we want that one and that one. We don't want this one, and we don't want this one. We only want the member properties. So we want all of those summed together. So let's try and write that. We want to prepare the compilation there, and result. Obviously, want to compile. That will give us a compilation result. And we'll use our cert source equals there to explain what outcome we want. So we want just public fun foo sum equals x plus y. That's the output we're aiming for. We're just aiming for the properties, the member properties typed as int. And where do we want those? We want those in a generate. Oh, where is it? And in a generator source for foo ext.kt. So just like that. All right. So that's our test. So the test is just to explain what we're trying to aim for. I'm going to clean that up because it's annoying me. So let's run our test and see what happens. All right. So we've got a failed test, and an operation is not implemented. And if we click on that, see it's in here. So what it's saying is when we want to test some Kotlin compilation, we have KSP symbol processors. We need to actually supply them there. So that's actually telling us what our next step is, which is quite useful. So we need to write a symbol processor provider. So let's have a go at doing that. So I'm going to make a main source set here. And we'll get a package and create a new file. So it's going to be int summable processor provider. Yep. Okay, and let's just close all the distracting things again. Okay, so obviously it's no good if we just have our class by itself and we haven't actually used the KSP API. So we need to implement symbol processor provider. And what is the IDE complaining about there? Well, we haven't fulfilled the contract for symbol processor provider. So let's get the IDE to do that for us. It's just one member we have to implement. And great, there we are. So we can see we've got this function called create. We have to return a symbol processor, and we get a handle on this environment here, this environment parameter. Let's just have a look at what goodies we get in the environment. So you see there we get a code generator, a logger, we get access to the Kotlin version, and then options which we can supply from the build.gradle. So that gives us a clue about what to do next. We need to have a symbol processor. So let's just declare that in the same file here, just to make our lives easier. Call it int symbol processor. And it's going to implement symbol processor. Oh, imported the wrong thing. All right. And again, we're getting a complaint from the IDE. So let's just, again, we'll just implement the members. And all right. Let's just put a hold on writing the body here and concentrate on finishing this part. So when we had a look at the goodies, what kind of in environment there, what kind of goodies do we need in our symbol processor? Well, obviously we need code generation. Might need the logging as well, so we'll put that in there. Now we can complete this, so we can do return int summable processor provider, or int summable symbol processor, and then just unpack the environment like that. Okay, so we've completed our symbol processor provider. Let's just move to the symbol processor now. So we've got this single function called process that we have to write. And let's just have a look at the docs there. So we get a resolver, which we essentially use to inspect the code. And then we have to return a list of deferred symbols. And we'll explain what that is later, but it's basically about getting your processor to play nicely with other symbol processors. So in other words, deferring processing classes when they don't have all their symbols ready, and you're waiting for other processors to fill that in. So right now we're just going to return empty list, but we'll explain a better option shortly. So returning empty list is just to shut the compiler up and just, so that for ease of explanation. So what are our stages here? Remember, we want to we'll write those out as comments just to show the general direction of what we're trying to achieve. So first step is to get the classes annotated with int summable. And then what we need to do is get the properties typed as int. So the member properties, not the extension properties. And finally, we need to output the code for the extension function. So 3 things we need to do there. Now, we don't really have anything to work with other than the resolver here. So let's have a look in the resolver and see if we can find a function for getting all of the annotations, or getting all of the classes annotated with int summable, which is our first step. And if I just type in annotation there, you can see there's only one match for the function, which is get symbol with annotation. So obviously that's where we're going to start. We just need the fully qualified name of the annotation. So just like that. Okay, so that gives us a sequence of KS annotated. Let's have a look and see what we can do with a KS annotated. So if I just use map and type in it there, you can see I don't get a lot there. I just get the annotations. I can look at the parent and the location. So not what I need. But if you remember, we said that our int summable can only target classes. So we can actually use that information to our advantage. So we can do filter as instance, and then KS class declaration like that. Now, when we look at what we get inside the map function there, you can see there's a lot more available to us. Get all functions, get seal subclasses, and so on. So a lot more to work with there. So we've done our first step, which is get the classes annotated within summable. So now we need to get the member properties typed as int. So let's just replace it with a explicit so that we don't get lost in, shadowing the implicit lambda parameter there. So, right, we have a KS class declaration and we want to get the member properties. So if I just use autocomplete and I type in properties, you can see we've got two choices of function here. We've got all properties, which includes properties from the superclass, and we've got declared properties, which are properties that are explicitly declared inside the class. So we obviously want get all properties. Now that's going to give us everything, and we have to filter. We have to filter out extension properties. So if I search for extension, you can see that there's this extension receiver, and extension receiver equals null is going to mean that we have a member property. So let's restrict ourselves to member properties using filter in that way. Now we want properties typed as int. So how are we going to do that? So by the way, the it is a KS property declaration. So I probably should have put on type hints in the IDE, but that's okay for now. Right, so if I do it type like that, you can see I don't get a lot. I get the element and the location and the parent and so on. So when we were talking about symbol resolution before, remember we said that at the level of the abstract syntax tree, everything is name only, and to go into the realm of meaning, you actually have to perform resolution. And that's what we're going to do here. So we're going to resolve the type for the property. Once we do that, you see we get a lot more information. We get the meaning. We get whether the type is nullable, whether it's assignable from this and that type. Now we just want to check if the type is invariant on int. So how do we get the int type? Well, these are actually inside the resolver. Resolver has a property called built-ins, which includes the common Kotlin types. Now, of course, if you're not worried about invariance, and you can use as assignable from, but here we can just use equality of type there, and there's no problem for doing that. So let's just materialize that to a list to make our lives easier, because we're just doing a toy annotation process. So we're not too worried about multiple iterations of a sequence and so on. Now we do need something to return from the map there. So let's just declare a really simple data class to hold the results from our map. So I can't think of a better name than data for now. And we're going to put the KS class declaration, because we'll need that in the next step. And we're going to put the int properties, which are typed as a list of KS property declaration. Okay, so now we can return that there. So data. Oh, we need to assign that, don't we? Okay, great. So we've done our first step, which is to, well, we've done our first step and our second step. So we've done get the symbols, get the classes that are annotated with IntSummable, and then our second step, which was get the member properties typed as int. So now we're on to our third step, which is to output the code for the extension function. So because outputting code is a side effect, we're going to use for each, and we'll just use an explicit lambda parameter there so that we don't get lost. Now, when we want to create a file using Kotlin Poet, we're going to write a file spec. There's a builder function there, and we need to supply a package name and a file name. So we're going to use a package name of the class decoration, so that we want the generated code to be in the same package as the class. So we can get that from our, so we want data. Oh, I was stupid. I made those private. That's why they're not showing up. Yeah. Okay, so I want the KS class decoration, package name as string. Okay, so that's given us the package name. And now we want the file name, so we'll do data KS class decoration simple name as string plus ext. So we want them in a file where, so if it's in foo.kt, we want the generated code to be in foo ext.kt. And we'll just clean that up, make that into a template. Okay, we've got our file spec. What do we need to add to the file? Well, we need a single extension function. So let's add a function there. And function is going to be from a fun spec. Fun spec is a set of instructions for Kotlin Poet to output some function. Right, so what's the name of the function we want to write? So we were, in the test, we're calling it sum. And let's just build that to kind of shut up the IDE. So what are the important things for a function? Well, important things are the receiver and the return type. Let's start with the return type. So obviously we want to return an int, and the receiver for our extension function is going to be the type for that class decoration. Now, if I look at receiver here, there's different overloads. There's KS class, which we don't have an easy way of getting. There's type, which is from Java Reflect APIs, and there's type name from Kotlin Poet. So let's aim for this type name here. So we want to start with the KS class declaration, and we want that as a type. So what is this type arguments here? Well, when you have a class declaration, obviously you can have type parameters like that. And when you want to actually resolve or bind those parameters, and you supply some arguments. And we're not interested in doing that here. We just do empty list. So that gives us a KS type. So we can go from that to a Kotlin Poet type name. So we've got the return type and we've got the receiver. Now we just need to add the code. So what kind of code do we want? Well, we want return, and then we're going to use L for literal and supply an argument here, and we'll be fancy and use join to string. So we want the properties, the simple name of all the properties, and separated by a plus. So if we can do join to string, and the separator is going to be that that plus symbol. And we're going to do KS property declaration simple name as string. Right, so that's saying join all the properties that we got in the previous step and separate them with the plus like that. And of course we have to build. Then we need to build our file spec. Okay, it's not enough to build, we have to actually write the code. So we get this write to extension function here, and we can supply a code generator. And if you remember, we put a code generator in the constructor arguments for our symbol processor, which we got eventually from the environment parameter there. So we need to actually do aggregating equals false there, and we'll explain what that is shortly. But that should be enough to get us started. And let's actually go and run our test and see if we've actually done something useful. So obviously we have to supply a list of, we have to supply our processor provider there, otherwise it's not going to work. Let's try running this code and see what happens. Okay, so we've got a difference in our expected from our actual. So we expected that. So just very, very simple file, but Kotlin Poet has been more precise, and it's added the return type, and it's added an import for Kotlin int there. So it's just a matter of adjusting our expectations. We're going to copy paste that there. Okay, and that's our passing test. So we've written a very, very simple annotation processor. If you want to have a look at that, the link is github.com/draws/Codegen with KSP, just like that. And there's other examples as well. So I don't know why I erased that. Right, so let's go back to our slides now, and we'll continue with the rest of the presentation. So fourth part is called the Great KSP, and we're going to explain some of the things we left unexplained when we were writing our annotation processor that might trip you up later. So one thing to try and understand is multiple rounds of annotation processing. So let's say we've got this builder processor. What it's going to do is it's going to look for this @builder annotation. And when it sees that, it's going to output a generated builder where you can supply the parameters piecemeal rather than all at once. And then for a really contrived example, we're going to have this hello processor, and it's always going to output the same content. It's going to output a class called hello.kt. So we've got two annotation processors in our project. When you're doing that, you might end up with this edge case here where you have a class where this hello is unresolved. So what you want to do in this case is you need to defer creating the builder until this hello class is provided by another annotation processor. So you want the annotation processors to behave nicely together so that one waits for the other to output before proceeding any further. Now, how do we do that? Well, if you remember when we were writing our symbol processor, we got this process function, which was really critical. And the output there is a list of KS annotated. And that KS annotated represents symbols that you can't process right now that you need to defer to another round. So a common pattern is to inspect the symbols in the class that you're trying to process. And if they're not valid, then just return them at the end. What does that look like? Well, round one, we have a builder annotation. The builder annotation looks at a class, which and it decides, okay, it's not quite ready yet because some of the symbols are not valid, some of the symbols are not resolved yet. Then we have our hello annotation processor. The hello annotation processor will output the hello, which the A class references. Then in round 2, the builder annotation processor can look at A class and see, okay, well, everything is resolved now. I can output the builder that I want. So you might think, okay, well, if we're using multiple rounds, and how do things stop? Well, if the builder has no outputs and the other annotation processor has no outputs, then processing stops. There's no new information that we can use to process any symbols. And anything deferred at that point will be logged as an error, because there's stuff that you're expecting to be processed in a further round, but there's no new information to help with these other rounds. So that was multiple rounds of annotation processing. Let's look at incremental processing now. So that's about making your annotation processor really performant and making sure you're not slowing down your builds. So you might remember when we were using Kotlin Poet, we had this aggregating equals false parameter that we needed to supply. So what's that about? Let's consider a very, very simple annotation processor. It's going to look for @interesting annotations, and it's going to output in a file suffixed with ext. Very, very simple extension function. So let's consider what are the inputs for that annotation processor. So in general, the inputs are the sources in that module. However, a.kt is especially important for generating aext.kt. So we're going to register that as an input, and that's represented by the black arrow in the diagram there. So the question we need to ask ourselves when we're deciding whether a processor is aggregating or not is, what happens when we add a new source? Can we add some kind of new source that will harm the aext.kt and cause it to be invalid? So, for example, if we add a b.kt and we add the @interesting annotation, all that's going to do is cause a bext.kt to be generated. It's no way doing that can harm the aext.kt and invalidate it. And it actually turns out whatever kind of crazy sources we add, there's no way to harm that relationship there, and there's no way for aext to become validated for some new source. So aext is protected from having to change, or isolated from having to change, and therefore it's called an isolating output. So we have two outputs, isolating and aggregating. So this one is isolating, aggregating equals false. All right, so you might be thinking, what is aggregating then? So let's consider a different annotation processor. It's still going to look at the @interesting annotation, but what it's going to do is aggregate or collect all of those into this output called fascinating.kt, and it's going to write a class where the parameters are typed after A, B, and C there. So A, B, and C are registered inputs. Can I harm this output by adding some new source? And obviously the answer is yes. If I added this _kt class, then fascinating.kt would have to change to look like this. So it would have to change to accommodate this new parameter in the constructor. So that would require rebuilding the outputs and reprocessing the inputs. So because that output aggregates or collects potentially new information from new sources, it's called an aggregating output. So if that's the case, You might think, well, aggregating is a bit of a useless optimization then, because we're always going to have to look for new sources. Well, there are still optimizations that you can have for aggregating annotation processes. So let's consider this case here. We have A, B, and C as register inputs, and we have D and E as inputs in general, but not register inputs for that output fascinating.kt. And what would happen if I deleted those classes? Well, obviously, if I delete D and E, there's no way I can add new information for that output to aggregate. So that can be deleted safely. And in this case, KSP knows that it doesn't have to reprocess and rebuild fascinating.kt. So this aggregating versus isolating is actually kind of tricky, but there's some good explanations in the KSP documentation. And also you can look at the Gradle documentation as well, because Gradle also has this concept of aggregating and isolating annotation processes. So last thing we're going to look at is called X processing. Now, if you have a legacy annotation processor, you're probably going to use this javax.lang.model API, and it's pretty much impossible to use just a small corner of that API. It's probably going to color your entire annotation processor. What do you do in this case? We actually need to migrate to KSP. So it's a tricky migration to perform, and you don't want to introduce any bugs. One approach that you could do there, which Yigat Boya, an engineer at Google, followed, is to write some kind of wrapper around the javax.lang.model API. So here we've wrapped the javax.element API. Once you've done that, what you can do is take your annotation processor, and wherever you have a raw reference to a javax.lang.model API, you can swap that out for your wrapper. And that abstraction, the X element abstraction, can have two concretions. So one concretion that forwards the calls to the old Java-C APIs, old Java x.model.lang. The old model APIs. And then you can have another implementation that forwards the calls to the KSP APIs. And that's a really elegant way of doing it, and a good example of using polymorphism to solve a problem. And that's going to allow you to continue to support Java consumers. Java consumers might not want to add Kotlin to their project just so they can use KSP. And it will allow you to, of course, support Java consumers and let them have a really nice performant annotation processor. It's not going to slow down their builds. If you want to see some PRs of that in action, there's some PRs here, and I'll post the slides shortly, and you can have a look at those. Just lastly, my name is David Rawson. I'm an engineer at a company called ClearPoint in New Zealand, which is a digital agency. And I'm on Twitter occasionally at D_RAWERS. And really happy to meet new friends around the world and talk at the virtual Kotlin user group. And hope you enjoyed the talk. Just post the image credits there.
Excellent. Thank you so much. And folks, you still have the chance to ask questions, because it looks like you explained it so well that no one has any questions left. So once you posted the slides online, I would highly appreciate if you could send us the link. I will add the link to the description of the video, and the first thank you is coming in. So yeah, nothing to add from me really. I really enjoyed the talk. Thank you for coming on. I'm not sure how late. What time is it for you?
Yeah, it's like 6 in the morning here in New Zealand. So
Yeah.
yeah, I was a bit of a tryhard and woke up really early for this project, but for this presentation. But like I said, I can't shut up about KSP. I think it's really cool. And if you're interested in details of how the Kotlin language work, I think it's really cool. You can become like almost like a language lawyer and like get really precise about how you reference concepts in Kotlin.
Yeah. Excellent. Yeah, this shows actually. There's a lot of energy in there, and so thanks again. I just remember that it is some kind of silly hours. So thanks for coming on that early. And hang on. Oh, there's one question coming in. When would you suggest a team to implement its own KSP code generation? It's a good one from Marcel.
Yeah. Okay. Good question. So the usual answer for something like that would be it depends. So writing an annotation processor isn't free. You have to maintain the annotation processor. You have to write tests for it, and so on. So there's some kind of trade-off there, isn't there? So there's so what you're looking for is a situation where you're having to write the same error-prone code again and again, and you want to reduce the chance of errors. You want to save developer time, save time and pull requests and reviews and so on. So I would say it's going to be a tool that you'll want to use for larger teams. I think for a team of 1 or 2, it's probably not worth it. You'll spend more time writing and maintaining the annotation processor than you'll save by using the annotation process to output your code. So it is a bit esoteric. So this talk's not going to be for everyone. It's going to be a tool that suits larger projects, I think.
All right. So I hope this answers the question. We do have a slight longer delay than usual, so I might have messed up the setup there. So give it a few seconds. All right. So I don't have any questions. I just know I have to watch it again to essentially get deeper into it. And you are on the Kotlin Slack as well, so I suspect when people have questions, they can bother you there as well.
Yeah, there's so don't ask me. There's really good engineers on the Kotlin Slack who know a lot more.
Yeah.
And there's a KSP channel there, and it does see the questions answered quite promptly. So if you do get stuck, and post your question there, and people are very friendly and they answer the questions.
Awesome. Even better then. All right then. I think thanks for the answer. Okay. Yep. Classic. It depends. All right. Let's wrap this up, folks. If you're interested, check out the links I will add after this call for the 2 talks or conferences with the closing the CFPs tomorrow. I will also add the link to the Java Advent CFP, which starts tomorrow, hopefully. And if you have any questions, hook us up on Twitter or on Kotlin Slack. You will find us. And again, thank you, David.
Yeah, thanks. It's been great to speak. Thank you very much.